mean different things, but at its core, it does have an underlying concern to protect the earth and humanity. Sustainability refers to the operation of a business without endangering the environment and all living things, and in a genuine sense, the entire earth. In another sense, it is the care that businesses take to preserve and enhance a healthy planet that is conducive to those who come.
It stopped.
Would you like to play it again?
Yeah.
After us. And that includes the atmosphere, the seas, the rivers, plants, animals, and of course, your descendants. The one species that is hell-bent on destroying the vitality of the earth, you disappoint. That is the human race. We want more wood, more meat, more fish, more poultry, more metals, and more chemicals. We destroy entire rainforests, excavate the mantle of the earth, and poison the atmosphere, and ruin the earth. So much so that it is no longer safe to live on this planet. The major culprits who do this are two: consumers and business. Manufacturers produce all those things which you cannot live without: medication, drugs, processed food, meat, fish, smartphones, paved roads, name it. Each destroys the earth in some way. What is ESG? It is customary to subdivide the concept of sustainability into three main areas: the environment, society, and governance. Now, the environment, you know what the ambiguous word environment means? It denotes the entire ecosystem on the earth, including the atmosphere, the seas, the watercourses, and all that is on the earth. What about social or society? The S part. Social is equally vague. It refers to society, but this may not be wholly true. It is all things that hold communities together. What about the word governance? Again, governance is unclear. It refers to man-made, whether it refers to international treaties, laws, or international laws and regulations is one question. There is a view that governance means how statutory laws or rules of conduct that companies set up to govern their business activities. Now, here are some examples of how global companies practice sustainability. Take Biogen. Biogen develops therapies for people suffering from neurological, autoimmune, and hematologic diseases. Biogen is a carbon neutral company. The company has effectively neutralized its carbon emitting business activities. Within the communities it operates, Biogen sends out thousands of employee ambassadors. Biogen specifically targets talented lady employees, which is fine. It guides these women into leadership roles. It also promotes a sustainable work-life balance for every employee. That includes a year-end shutdown and employee sabbatical programs. Now look at another company that's related to sports, Adidas. It's a German-based company with operations around the world. Adidas manufactures Adidas and Reebok branded sports equipment. Adidas approaches the concept of sustainability by balancing shareholder expectation, respect for human rights, and the needs of its employees. This it does by providing the best lifestyle for its employees. By a creative scheduling process. Employees can earn flexible time off. Adidas employees each have what is known as a time account. It lasts the duration of the working life. Employees bank in time, not money, which they earn by doing certain activities. They use this accumulated time as paid vacation, sabbaticals, or early retirement. Also, the company practices a unique parent coup. This initiative allows parents to continue on a part-time basis without losing their employment status. In fact, in some locations, Adidas offers nursery rooms and fully equipped temporary offices which are child-friendly. We move on to Kasim, Finland-based grocery retailer.
Okay, I'll stop it there. If I go back to the previous slide, you will see that I provided the contact as well, I mean the website as well as who this is from. This is actually done by a lawyer, Mr. G.K. Ganeshan, and the link to his video is shown in the slide. Many countries and companies have pledged to reduce their GHG emissions. Our companies here, IOI Edible Oils and IOI Bioenergy, have been working on this too. And now here I will share some of what we have done in our complex here in Sandakan. Okay, this, what you see here is our Sandakan complex. You'll see it's actually bordered with a lot of greenery, which we try very hard to maintain. Over here, you see our bioenergy complex. It's a cogeneration plant that produces both steam and electricity by using the waste from the palm oil mills as fuel. So it is a net zero plant. There's no considered as no carbon emission from this plant. That plant supplies its steam to the neighboring IOI edible oils complex. What you see here in a row here are the 3 refineries, and nestled together with refineries are fractionation plants. So these are the main consumers of steam from the neighboring complex. Over here we have the kernel crushing plants, which consume power from the complex, from the neighboring plant. This is the highest power consuming plant in this complex. You will see here, you can see the scale. This is a picture taken from a drone, and this is the size of a tanker. This is a cargo load about 40 tons, and you can see how small, how tiny it looks. And on the right-hand side here, the bottom right-hand corner, you will see the effluent treatment plant. The water that is processed in this plant is reused in the refinery, not for food applications, but for utilities. Over here, we have a palm kernel dry fractionation plant, and that's another area where we have also implemented many energy-saving projects. And you will also see wherever we can, we maintain the greenery. You'll see a lot of greens all around the complex. You'll also see this in an aerial view. This is the biomass complex, the same biomass complex over here. Oh, another thing I didn't mention, if you see the ponds here, there are also another 2 more ponds behind this plant. This is where we get our water from. Rainwater is actually used for powering this whole complex. We do not have supply from JBA or JKR. It's our own collected water that we treat in our own water treatment plant. And even the tea that we drink is made from that water that we process internally. Okay, this is an aerial view of the complex. This is the biomass plant, like I pointed out. This is the kernel crushing plant, right? And you'll again see here, this is the main office, and you'll see everywhere that we can, we try and keep the greeneries. If you zoom in, you'll find that along this pipeline as well, you'll see all the greeneries that are planted around it. So we try and maintain all the greens that we can in the complex. We're also one of the largest tank farm operators in the Sabah, with about 64 tanks. And we also have a jetty that's connected to it. So the pump house here, these 2 pump houses pump products straight onto vessels. So this is what we call the lauric tank farm, because we process palm kernel oil. And the bulk of it is actually palmitic storage tanks, which stores the derivatives from crude palm oil that is processed in our plant. This row here is the refinery complex, refinery 1, refinery 2, and refinery 3. And like I said earlier, nestled with it are also the dry fractionation plants. Okay, I will talk about let me hide this, huh? Right there. Okay. Some of the things that we've done here, we actually have got like I said, I've showed you just now, we have a long pipeline that supplies steam over to the complex. And there are many areas that steam is utilized. So we also do install a lot of steam traps and collect the condensate. So the condensate is used for lower grade heating applications. We also have an award-winning Wendy economizer project that we did. We've also done quite a few inverter and LED light projects, converting most of the spotlights in the complex to LED lights, and also using inverters for selected applications. We are the prime mover for converting the whole of Sabah to use liquefied natural gas versus diesel. The refineries here have now converted to using liquefied natural gas. And liquefied natural gas is actually more environment friendly than diesel. I'll also show you a major heat recovery project that we did in the refinery. Our kernel crushing plants, we've also installed dust plants here to trap the fugitive dust and vapors that comes out from kernel crushing. I'll show you some pictures of the results after we've done it. I'll also talk about the effluent treatment plant and what improvements we've done there. We're also working on converting palm oil into a biolubricant. So we're doing for the research here, and we've already started using in a few of our pumps. I mentioned earlier, we have a biomass boiler, which also generates ash, and that ash ends up as fertilizer back into the estate. So it's very circular. The waste from the mill comes to the biomass boiler, it generates steam and power, the ash then goes back as fertilizer. In one of our other boilers, we have installed a water scrubber. Again, the ash is collected and supplied as fertilizer. And we've also got a new boiler, which has got a dust cyclone as well as electrostatic precipitator for trapping the dust, and that again is sent to the estates as fertilizer. Okay, let me begin with okay, some of the practices, like I said, we have got refinery, dry fractionation, kernel crushing plant, palm kernel dry fractionation, effluent, and we also got maintenance electrical people here. So some of the things that we've done here to save energy and reduce the greenhouse gas emission from the whole complex. We have an energy management committee, which meets every 2 months. We've also got a registered energy manager who has to submit his reports to Suruhanjaya Tenaga or Energy Commission every 6 months, reporting on what savings have been done and what has not been done as well. And this has also helped us reduce our carbon footprint. Okay, like I said, we have got a lot of supply of steam into our plant, and we have in strategic locations installed condensate recovery tanks. So the condensate from the steam traps are channeled to these tanks, and then it is used for lower grade applications to heat up, like for instance, the palm kernel steering tanks or even the steering tanks. And it has helped us reduce our steam consumption quite significantly. And you can see here, I've mentioned here, where in the palm kernel dry fractionation plant, where it used to be 110 kg of steam that was consumed per ton of product, they managed to reduce it to about 65 kg per ton, which is a 40% reduction in steam consumption. And another thing is, because we're not so dependent on steam, we're using the condensate, we are able to run, even if there's a slight steam interruption, the condensate will see the plant, keep the plant running for a longer period of time. This is one of the things that we have done. Now, continuing upon this, right? Areas that we've recovered the condensate also and use it is also for CPO washing. We're one of the first plants in Sabah and probably in Malaysia that have installed CPO washing to reduce the contaminants in processed palm oil. And it requires the use of hot water. So rather than use steam to heat up the water, we actually recover the condensate and use it for the CPO washing process. Other areas that we use it for are for steering cake heating. So the palm kernel steering cake is not typically discharged about 25 degrees. It's a solid, a very hard solid. So it is then heated using heating coils inside the tank. And with our new system, we use condensate. Of course, whenever we start up the plant and there is no condensate available, we may use steam to heat up the water initially. This is for the palm kernel dry fractionation plant. The similar thing was done for the dry fractionation plant as well, where originally they were heated using steam coils and steam fins. We've converted to using condensate. And in some cases, we've had to also add in a heat exchanger in order to ensure there's proper heat exchange and heat recovery to ensure sufficient melting of the stearin. Now, an added bonus from doing this is that the quality of our products have improved, because when you use steam, the temperature is actually higher than 100 degrees. And that can, as you know, right, the higher the temperature, the greater the rate of reaction, the greater the rate of decomposition. So there's more deterioration in the quality of the products. By using a lower temperature, by using condensate, they'll probably come in anywhere between 70 to 90 degrees, right? It has helped to actually preserve the quality of these products better. Now, like I mentioned here, you've got these condensate tanks, right? And as we're walking around the plant, one of our smart engineers, he saw, hey, there's this vapor coming out from the condensate tank. Why don't we try and recover this heat that is available in this vapor? So that's what we did. And this vent economizer is this unit over here. It's basically a compact heat exchanger into which water is fed. So that water that is fed here is heated up and it goes and is used in low temperature heating applications. And all this vapor will then be condensed and dropped back into this condensate tank and is used for heating purposes as well. Now, this was implemented in the dry fractionation plant, and you can see here the steam consumption started dropping from 25.5 kg per ton of palm oil. It started dropping over the years as we started implementing more vent economizers around the complex, and it dropped to about 20.5 kilograms per ton of product. And the latest result is also around 20.4 kg per ton of product. Now, one of our engineers who sits in the energy management committee, but he's in the palm kernel fractionation plant, saw this being done in the dry fractionation plant and decided to copy it. And you'll see where it was actually initially consuming 100 and in excess of 110 kg per ton of product in the palm kernel fractionation plant. By implementing this, we were able to bring it down to about this level, 67 kg per ton. Now over here, what's happened is actually it dropped lower, but what actually happened was there was actually leakages of steam from the steam traps that were going to the plant. The latest result is, again, after we've addressed these leakages, it has actually reverted back to about 65 kg per ton. So the expected consumption now is about 65 kg per ton. However, the engineer is still looking at new ideas of how to improve this consumption further. Now, on the right-hand side here, you'll see that in 2018, we won the IChemE award in the palm oil category for heat recovery using the vent economizer, awarded by the Institution of Chemical Engineers. Now, another thing that we've done all over the plant is actually, wherever required, we've actually started installing inverters in order to optimize the operation, where previously pumps were being throttled, right? When you throttle the discharge of the pump, let's take this graph, for instance. If you're reducing the flow to about 60%, by throttling the discharge of that pump, you'll still be consuming about 85% of the power normally consumed by that motor. However, if you were to reduce the speed by using an inverter, it'll only consume about 20% of that power to deliver the flow that you want, right? So we've installed quite a few of this in selected areas in the plant and have been able to reduce our power consumption as well. This is one example that is worked out here, showing where we've reduced the consumption. And for a particular pump, it works out about 4,000 kilowatt hour per month savings. So that's in Sabah terms, it's about close to 2,000 ringgit a month savings in electricity. So it's quite sizable. And another thing we've done is we also installed air compressors, inverters for our variable speed drives for our air compressors. If you look at a lot of air compressors, you'll see they actually run stop when they achieve a certain pressure. And you'll realize that during this startups is when the most power is consumed. Now, in order to avoid this frequent start-stops, we started running the compressor between these two pressures so that it will actually deliver the required pressure to the plant without having to cut in and out and incur a lot of power. This is another thing that we've done to reduce power consumption in some of our plants. So we grouped up all the savings that we've done in the plant, and we look at heat exchangers, inverters, and LED lighting that we've done, right? Starting from 2017, you'll see that the amount that we have saved in terms of energy has kept increasing. Now we are saving about 2.3 million kilowatt hours. And in terms of cost saved in US dollars, it's 163,000, about $500,000 ringgit savings. The inverters are installed on, these are the pumps, cooling tower pumps, and there's a cooling tower in the background. And the inverters are installed on selected pumps. This is what the inverter looks like in the startup panel, or the control panel for the pump. And these are the cooling tower fans above the cooling tower. And again, we install inverters so that when the temperature of the water is very low, we can actually reduce the speed or even stop a particular fan. This is the LED lights that we've started using in the tank farm. So previously, where we're using spotlights, we've actually converted to using LED lights, which have got a lower carbon footprint, less energy being consumed, less energy wasted. So these are some of the areas we've actually managed to implement our plan, reducing our carbon footprint by reducing the energy being consumed, as well as resulting in financial savings for the company. Like I said earlier, we started the talks with Sabah Energy Company in order to put up tanks in our various refineries in order to receive liquefied natural gas. And I'm proud to say that over the last few years, most of the refineries in Sabah have converted to using LNG until SEC is already sold out on its gas. Now they've got to look at putting up a second train. And you'll see the reason we've done it is because LNG has got a lower emission factor compared to diesel, which is rated at 0.088 kg carbon dioxide equivalent per megajoule compared to 0.07 kg carbon dioxide equivalent per megajoule. So we have also tried to reuse foundations and avoided a lot of civil work. So no piling was done for this particular project. Okay, this is an interesting heat recovery project that we did for one of the refineries. Let me show you the next diagram. Okay, this is the initial configuration of the plant. BPO is bleached palm oil. It flows into a falling film heat exchanger, which then goes into a final heater, again a heat exchanger, which then goes to the pre-stripper. The oil goes to the pre-stripper, to the deodorizer. The very hot oil comes back and heat is recovered in this falling film heat exchanger, and then it goes for final cooling, and you have your RBD palm oil, refined bleached deodorized palm oil. Now, over the years, this unit started to get fouled, and when we shut down, we didn't have enough time to do caustic cleaning, so we were losing out on the heat exchange, and our consumptions were increasing. We do clean it, but it was not able to clean it sufficiently. So the manager in charge of the plant suggested putting in spiral heat exchangers. So we invested in spiral heat exchangers. And so the bleached palm oil then goes to spiral heat exchanger, then follows the same route to the final heater, pre-stripper, deodorizer, back to the spiral heat exchanger, and you get your product RBD palm oil as well. Now, when we did this, we did not remove the falling film heat exchanger. We left it there, but we blanked it off. And I mean, we isolated it from the spiral heat exchanger so we could run the spiral heat exchanger and avoid going through the falling film heat exchanger. Now, we ran this configuration for many years, and then the engineer suggested, hey, we've got time now. Why don't we do a long cleaning of the falling film heat exchanger to get all the gums and all removed? And how about we install it back in series? That means the bleached palm oil goes to the spiral heat exchanger, then comes up, goes to the falling film heat exchanger, then next to the final heater, and then follows to the pre-stripper, deodorizer, and back to the falling film to recover as much heat as possible before it goes to spiral heat exchanger and into our product storage tanks after being cooled. And if I go back to the previous slide, you will see where in 2014, the energy, the diesel and gas consumption was 5.73 liters per metric ton of palm oil. In 2015, when we did the cleaning, we were able to reduce it by about 10%. So this was with the falling film only. Then in 2016, after we installed the spiral heat exchanger, there was a 31% reduction in the fuel consumption. You'll see it dropped from 5.73 dropped to 3.93. We've used 5.73 as our base year figure, baseline. Then it started going up. We did cleaning again of the spiral heat exchanger, and it we were able to maintain about 36% over the few years, right? It stabilized around here. Then the engineer put back the falling film in series with the spiral heat exchangers, and you'll see that it has dropped significantly to 50%. So where we initially consuming 5.73 liters, we now dropped to 2.89 liters. Now, over the past few years, you'll see they has started to improve, but subsequently it is due for a cleaning. So we've got to plan for a cleaning of the heat exchanger very soon. So you can see during this period, we also switched from diesel to liquefied natural gas, and that's why the figures are shown here. So the figure that's shown here is an adjusted combined figure of using diesel and LNG. So you'll notice that the LNG consumption has reduced, and the annual throughput of the refinery will give us a savings of about 160,000 standard cubic meters of liquefied natural gas, which amounts to cost savings of 240,000 and a reduction in the CO2 emission of about 460,000 kgs or 460 tons a year, quite substantial reduction just by doing this heat exchange reconfiguration. Okay, let me leave you with another video now, which is by a World Wildlife Federation, and there is no voiceover on this. There are words, so you'll have to read it. So pay attention to the video. It's about global warming and the effects. Okay, scary, isn't it? If you look at the consequences of the melting of the polar caps, right? We're already concerned about the rising sea levels, and also the higher temperatures also have another worrying concern that I will cover in the last video later on. Okay, having covered about the effects of global warming, perhaps we can better understand why there is a need for industries and communities to look at leading a more sustainable life. Let me show you some of what we have done. In our kernel crushing plant, we have steadily increased the yields of the plant. This is the yield of the kernel crushing plant. And you'll see it has dropped this year. This particular year it has dropped. I know it's not the full year yet. However, it's unlikely to recover to this level. It's mainly due to the poor crop coming in for this year, affected by the COVID and lack of manpower in the mills and estates. Okay, but what is interesting is we've actually kept it above 46%. This is a challenge for many industries, many kernel crushing plants. So we kept it above 46% over these years. And at the same time, if you look at it over here, the power consumption actually reduced. These are actually supposed to work in the other way. If the yield is improved, actually involves greater pressing, which should actually result in higher power consumption. Yes, if you ask me, why did my power consumption jump here? It's because we actually installed dust mitigation plants, dust plants in the kernel crushing plant. So there was an increase in equipment being installed there to trap the vapors and the dust, right? But despite installing that, or in spite of installing that, over subsequent years, we've actually pushed to actually reduce our electricity consumption or unit consumptions. And another thing that is impressive here is that, okay, again, with the increasing yields, that means more pressing being done, you expect more wear and tear. But we've actually been quite innovative to actually keep our maintenance costs down. This maintenance is actually due to wear and tear of the presses. So the team here actually works very hard and try to implement very innovative ideas to try and keep the plant running at high yields, lower unit power consumption, as well as maintaining the maintenance costs. So this is what I was mentioning about. These are the dust plants that we install for each of the kernel crushing plants. The 3 kernel crushing plants here. The background there is a silo where we store the palm kernel. And this is what the plant, kernel crushing plant looks like with the dust plants in operation. So you see hardly any vapors or dust in the plant. What you see here are the downcomers to each of the presses connected to a duct that carries it to the cyclone over here, where the cyclone separation. The collected palm kernel expeller is then fed back into the plant. The dust is collected is actually a product which is actually sold for animal feed actually. Actually, from the palm oil industry per se, right? This refinery complex, there is no real waste being generated. It's quite circular. Everything can be used and sold. Okay, I mentioned earlier that we're one of the first few companies to install CPO washing. Now, CPO is crude palm oil. This is what it looks like. We've stuck in our IOI logo inside, and you can see it's quite opaque. You can't really see through the liquid. But by just washing it, you can see that the appearance will suddenly become brighter. And what we found from just washing the CPO is it would reduce the amount of bleaching agent that we need to use, or bleaching earth, as a result of which we would have lower oil loss. Because there is oil loss in the bleaching earth. CPO washing removes most of the water-soluble chlorides, which then helps address the 3-MCPD issue in refined oil. These are one of the contaminants found in processed palm oil. And it also reduces the phosphorus, metal ions, and impurities that can inadvertently end up in the CPO due to plantation mills and mill processing of it. Now, I mentioned that there is no waste from the palm oil industry. Now, this bleaching earth is used to remove the impurities in palm oil during the bleaching operation. And when it is discharged from the process, there is about 20% oil stuck to the bleaching earth. Okay. Now, this bleaching earth is then supplied to a third-party company who recovers or extracts the oil and supplies it mainly for non-edible users. Actually, exclusively for non-edible users. Now mainly for biodiesel and that kind of application. It can be used for soaps and detergents as well. I think currently it's mainly used for biodiesel applications. It's actually classified as ISCC, International Sustainability and Carbon Certification. So it has a premium attached to it, and it is supplied to mainly to the European markets and used in the diesel industry. So again, just to clarify or to let everybody know that there is really no waste that is actually generated by the process that cannot be used. So it doesn't become raw material for some other application. Now, when we did the CPO washing as well, the water stream had very high oil content, and this increased the load or the burden in the effluent treatment plant. In order to reduce that, we had a purpose-designed settling tank fabricator, and we're able to reduce the oil content significantly to below 1,000 ppm, so that this could be easily processed by the effluent treatment plant. Even the effluent treatment plant water is actually reused, but not here. So we were able to reduce our oil loss and recover more oil from the washed water. This is what the water looked like before we installed and recovered using the settling tank. You can see now it has become very much lighter and easier to process in the effluent plant. If it were very high COD, it creates a very great strain for the reactors or the bacteria in our effluent plant. Yes, we use bacteria for the sequential batch reactors in our effluent treatment plant. I'll explain that later. Okay, we do a lot of water recycling in our plant. There is, like I said, we have our own treated water, and for some applications, it goes through reverse osmosis process after the basic water treatment. Now, if you're familiar with the reverse osmosis process, maybe about 15 to 20% of the water that's treated will become rejected water. Now, that rejected water, we try to use it. So we minimize water being wasted. And so this is the amount of rejected water that is recycled already. We're trying to increase this further. And this is showing the amount of effluent water or treated wastewater, two different water streams. This is treated wastewater that we are trying to process in our plant, and it's also recovered. And these are some of the applications where we use it for cleaning, for tankers. Even during one of our cooling towers is designed to actually use RO reject water as well. It's actually purposely designed so that we can actually minimize the wastage of water. So we thought about all these things when we do new projects in this complex. Okay, the effluent treatment plant, we have sequential batch reactors, which were actually operating for something like 16 hours aeration. These are the diffusers in the reactors, where air is bubbled through the reactor. You can see the bubbling action taking place over here. And it used to be running for something like 16 hours. We did some optimization, and we were able to reduce this aeration time significantly. We were able to reduce it, and as a result, reduce the electricity consumption in the effluent treatment plant. We've also managed to shorten the process, bypassing some of these processes, and reduce chemical usage in the process as well. So again, reducing our carbon footprint. Previously, the sludge that was generated was actually disposed of, but now, since all of the waste coming from the refinery is actually organic, we send that sludge back for digestion in the reactors. And it is possible for the bacteria to totally digest and reduce the COD of our water. Now, this is something that we're working on in our complex. This is a pump. For those who are not familiar, this is a centrifugal pump. And we've actually been using olein, or even olein with additives and stabilizers, antioxidants added in order to be used as a lubricant. Fortunately for us, the viscosity of olein, the natural viscosity of olein, matches that of the lubricants being used for pumps. So it can immediately be used. But the problem is the stability and deterioration of olein or palm oil derivative due to oxidation and high temperature application. So we're actually doing some experiments to try and enhance the life. And I'm proud to say we've actually been running this for about more than 6 months now, and it's showing positive results. We've also managed to work with a third party who has suitable additives and ingredients, all made from palm oil, to be added into the olein in order to be used as a lubricant. Now, one of the problems being faced by edible oils is that there are trace amounts of mineral oils being found in processed oils. So it has become an issue of complaint by the West. And so this would be a very good initiative to convert the industry to use our own product and create demand for our own product as well, and ensure that no lubricant contaminates our edible oils. I'm sure you wouldn't want your family members or even small babies to be consuming mineral oils. So this is a good way to actually use our own product to address that challenge. Okay, this is our biomass boiler. This is not a biomass boiler. This is showing you that our biomass boiler, which was using about 1.8, was only generating about 1.8 tons of steam per ton of fuel use. We managed to improve the performance over the years. I haven't got the latest figures updated here. It's around, it has dropped slightly because we're having issues with the quality of the feed and the moisture content in the fuel. So it's dropped a little bit, but we're able to use the waste from the palm oil mills, which is what this is what it is. These are the fibers. They are actually shredded in either the mills or in our facility itself, and then fed to the boiler as fuel. So our boiler operates purely on this to generate steam and power. This is a ratio that we try and monitor how efficient it is in generating steam. We're actually putting some improvements here to try and improve this further. We've done a new boiler which has got an improved grate system, which has got internal drying, so that the fuel goes into a drying zone first before it is combusted. That helps to improve combustion. By the way, I think I did mention that this fuel typically comes with about 50% moisture. So it's a difficult fuel to handle. And we have to evaporate that fuel in the boiler. So we're trying to become as efficient as possible. Now we're also trying to do some drying outside the boiler before it goes into the boiler to try and improve this further and reduce our fuel consumption as well. Okay, this is the new boiler that we put in, a high pressure boiler, which also feeds to the power plant. And you will see that we have got economizers installed here, and this recovers heat from the exhaust gas. You see, this is the fuel being fed into the boiler. We have the fibers that I showed you just now fed onto, this is the grate. Now, the first part of the grate is considered as a drying zone, where we actually have a stream of gas from the outlet here being fed back under the grate to dry it up. Because temperature is about 150 degrees, it will help to reduce the moisture content of the fiber before it goes into what we consider to be the combustion zone. And this is finally what we call the ashing zone. Then from here, it comes out, it's collected and goes as what I said earlier, as fertilizer. Now, what comes out from here, the flue gas that comes out from the boiler, goes through the economizers, right, to preheat the boiler feed water. And we are able to heat the water up to about 260 degrees. And so water goes in at already very high temperatures into the boiler. This is the cyclone. Again, from here, the ash is collected and goes as fertilizer. And again, finally, it goes into the electrostatic precipitator. Again, the ash is collected before the flue gas is pushed out the chimney. This is a picture of the electrostatic precipitator and the chimney. Beside it is the induced draft fan. ID is induced draft fan. You can see the ducting coming out here goes down to the fan. You can see some bags at the bottom here. That's where we collect the ash for supply to the estates. Okay, the improvements that we've done. Now we have a biomass boiler, which used to have boiler feed water temperature of 108 degrees. With our earlier cogeneration plant boiler, we were able to heat it up to 220 degrees. But now with the new boiler, it has gone up to 260 degrees. Very good heat recovery using an innovative concept using what we call heat pipe heat exchangers. One of the problems with the palm oil industry is due to the temperatures and the moisture content. There's a lot of concern that there will be condensation of sulfurous or acidic gases that would actually shorten the life of these economizers. But this heat pipe exchanger keeps the two stream, the hot stream and the cold stream apart, so that you can actually use them safely in these applications. But that's why we use them. In our previous cases, the life of the economizer, you can see here, in this boiler, it's only 1 year. Here we managed to get 5 years, and here we expect to have more than 5 years. This boiler is now less than 3 years old, so we cannot say for sure, but so far it's performing very well. We check the performance every year, the thickness of the tubes and all that, and we're quite happy with it so far. With our previous boiler, we used to have to use a lot of palm kernel shell compared to the fiber, 25%. With the cogeneration boiler, it came down to 10%. And with the new water tube boiler, it has dropped to 5%. Shell is a very compact hydrocarbon. So it is a preferred choice, but it's a very expensive fuel. So we try to use more fiber. You can see also the extent of fuel combustion has improved from what it was 90%, dropped to 85% with the cogeneration boiler, and now it's back up to 95%. It's improved. And it's able to handle, like I said earlier, it's able to handle high moisture content in the fuel. What you will see as our previous steam to fuel generation and what we are getting now. And also the cleanings, you'll see it has improved. We can actually go even to 90 days before we have to shut down the boiler, which gives you higher uptime before the ash is built. But in order to do this, what we did is we had steam soot blowers as well as shockwave soot blasters that were incorporated into the boiler. Let me just go back and show you. In a lot of these areas where ash can accumulate, there are steam soot blowers, and we've also put in shockwave blasters to blow away the ash. And the ash is collected, comes out here and is collected. Similarly, on these economizers as well, we put shockwave soot blasters. So we have a controlled detonation using oxyacetylene, oxygen acetylene gas, to create a minor explosion that rattles the dust, creates some shock inside here, and pushes the dust out, and is collected in the dust cyclones and in the electrostatic precipitators. Okay, I also mentioned we've got a scrubber system for our ENCO boiler. Again, this is using water, and it captures the ash and dust. And this is also supplied to the estates as fertilizer. This is a closed loop scrubber. There is no effluent that's generated from it. The water is actually just recirculated within the system. Again, you'll see where we had emissions of 300 milligrams per normal meter cube, it has dropped to below 150, well within the permissible levels given by the Department of Environment for this type of boiler. Okay, now let me just give you a summary of our greenhouse gas emissions and what we've achieved in terms of reduction. We've used the year 15-16 as our base year, and you'll see where we had 35 or 36 kg of CO2 equivalent per metric ton of product. We've done projects over the years to try and reduce it, and it stands currently at 25.92 kg of for the palm oil. For the olein and stearin, this olein and stearin, let me explain. For those who are interested, my colleague, registered chemist, Ms. Yong Yen Lee, will be doing a presentation on the palm oil refining process, and also will show a video to walk you through the plant and show key processes tomorrow afternoon. So please do attend that if you would like to get more information about the refining process. So the palm oil is fractionated into olein and stearin. So these are the products that come out from fractionation. And here we have it also reduced by about 50%. From 23, it has dropped to about 12%, 12 kg. From 23 kg, it has dropped to 12 kg. Crude palm kernel oil, this is from the kernel crushing plants. This is very high energy usage plant. So it's dropped from 129 kg to 92 kg. The co-product from the kernel crushing plant, which is the palm kernel expeller, has dropped from 59 to 42 kg, and so on. You can see that in all cases, we are working on reducing the carbon footprint. And the overall, if you look at it, which was originally 42.58, we've dropped to 28.52. And we're still working on newer projects to reduce this further. And this is a graphical view of it. You can see the reduction in palm oil versus reduction in olein and stearin. And this is for the lauric products and for the olein and stearin from an RBPK, olein and stearin is dropped. Now, what I tried to show here is some of the major sources of pollution, methane from the cows as well. So eating beef, eating meat releases a lot of methane, and also from these plants are also the major contributors to the emission of carbon dioxide. Carbon dioxide and methane. So carbon dioxide is the main contributor, comprising about 82%. Methane is 10%. But in terms of intensity, methane is 28 times more potent than carbon dioxide, and nitrous oxides are almost 300 times more potent than carbon dioxide. Normally, carbon dioxide is taken as 1 in terms of its global warming potential. Methane is 28 times more potent, whereas nitrous oxides are 298 times more potent than carbon dioxide. But it's all calculated based on carbon dioxide equivalent. Now, this is our figure that we have showed you earlier. What it was at 15-16, and what we achieved as at current, as at February, 28.5 kg per metric ton. But our target is actually to achieve about 40% reduction by the year 25-26. So we've still got a ways to go, and you know that in some cases our products are still very high. And by 30-31 to achieve 45% reduction. So our group has set certain targets to be achieved within these timeframes, and we actually have to report on our progress every year. So we're very serious about achieving these reductions. Now, another interesting thing that we've done here, like I mentioned, is that our biomass boiler is a cogeneration facility which generates steam as well as power. We commissioned that plant in November 2019, right? And since then, we had some problems in the year 2021, and you'll see that it has jumped in the year 21-22, even though it's not, the whole year is not over yet. Whereas for the next financial year, we're expecting to be about the 35 million kilowatt hour level. Now, this green energy that is generated by this plant also helps to reduce the overall carbon footprint from the complex. Okay, now, you've just been listening to me and you may think, oh, Shyam is just saying whatever he wants. I put up some pictures here to show some of the awards we have won over the years. Earlier, I showed you the IChemE award that we won in 2018 for the palm oil category. In 2018, for the first time, we participated in the National Energy Awards, and we emerged as champions for large industry category, winning a prize of 50,000 ringgit. This is a certificate that was awarded together with it. And we were also selected to represent Malaysia at the ASEAN level. You can see our names here. And we emerged as second runner-up at the ASEAN level to show that Sabah boleh and Malaysia also boleh. Now, this is the KCP, also an award-winning plant. It has won earlier again in 2012, 2013, and now again in 2017-18 as the best kernel crushing plant in Malaysia. You can see with the high yields and the dust-free environment why it wins. You also see that our dust plants made the cover of one of the palm oil magazines. This is the award that is awarded by MPOC after they audit all the kernel crushing plants in the country. Now, in 2021, we participate again in the National Energy Awards, and our biomass plant won in the cogeneration category, winning a 40,000 award. This is the award and the certificate issued to IOI Bioenergy, the cogeneration plant that I mentioned. And we've also participated this year, and we have been asked to submit to ASEAN, which means that we should be well placed in Malaysia category. And we are representing Malaysia at the ASEAN level for both IOI Bioenergy as well as IOI edible oils. Between 2018 and 2021, if you ask why we didn't participate, there was a rule passed that you cannot participate if you're a winner. For 3 years, you cannot participate, you're excluded from participating. However, this has been clarified now that you can participate as long as it is different projects. So now we're using different projects and different submissions. In 2022, we won the group annual innovation convention for the IOI group. And again, the bioenergy plant was awarded the winner, beating the other refineries and even oleochemical plants in the group. This is the trophy that we won. And the actual winning project was something that cost less than 50,000 ringgit to do, but ended up in a huge greenhouse gas savings, as well as, if you convert to ringgit, it was about 6.1 million ringgit savings, just from a 50,000 ringgit project, less than 50,000 ringgit project. Now, before I end today's presentation, I want to leave you with another video.
Is there an animal humanity feels more conflicted about than the bee? They're kind of cute, right? And they can give us delicious things like honey and useful things like beeswax. But they've also got those infamous stingers. Bees can be a little scary, and in swarms, they can be deadly. So when reports hit the news about colony collapse disorder, some of us might have thought, well, what's the big deal? Are the apophobes right? Are bees worth the risk? What would happen if all the bees died? Unfortunately, we'd lose a lot more than baklava and organic candles if bees went extinct. There are more than 20,000 species of bee in the world. Together, they are probably the most important group of insect pollinators. If all the bees suddenly disappear, there would be a vacuum in our ecosystems that would be very hard to fill. Many bees have co-evolved with flowers so that they are a fundamental part of those flowers' life cycles. These plants would likely go extinct without the bees. Other plants that bees pollinate might survive with other pollinators, but they would be at a disadvantage. Blueberries and cherries rely on bees for up to 90% of their pollination. We could be looking at a dire situation in the pie industry. There are also animals that rely on bees for food. If we lose the bees, some of our most beautiful natural species could be next. All these changes would have ripple effects throughout ecosystems and into human society. Humanity probably wouldn't starve without bees. Fortunately, many of our staple grains are pollinated by the wind. But nutritious fruits and vegetables could be lost or become so expensive that few people could afford them. And eating healthy is hard enough as it is. It's hard to know just how such a huge change to the natural world would end. By disrupting a key link in the food chain, we could be changing our entire way of life. It's lucky this is just a hypothetical, right?
Okay. Sustainability, global warming, and bees. What do they have in common? Well, humans, while changing the climate, have also made dramatic changes to Earth's landscape. The increasing human population and our demands for space to live and grow food has meant that more of wildlife habitat has been changed into urban and intensive agricultural use. This results in loss of habitat and food sources for bees and insects, as well as exposure to potentially harmful pesticides. Again, large areas of single culture crops affects bees and insect habitats that are required for native bee food and nests. The crops may not provide a suitable food source for certain bee species, such as the honeybee, which suffer compromised immunity when only fed one source of pollen. And again, with global warming, you will notice that there is a decline in bee population globally. You can Google up and read about this, right? So you have, with global warming, you've got rising sea levels that could actually wipe out certain coastal areas, so you lose agricultural lands. Human population demands a lot more land for food, for vegetables, for meat. And if we lose bee population because of increasing global temperatures, we'll have less pollination. We may lose out on a lot of food sources that we were able to rely on previously. Are you aware that of late, many climate scientists are protesting about global warming and are being arrested? Just Google scientist rebellion, and you will know what I'm talking about. They feel the urgency and are of the opinion that our governments are not doing enough. Now, since this is the hot topic these days, undergraduates should become familiar with it. If you can, include elements of sustainability and greenhouse gas reduction in your thesis and projects. It may just help to differentiate you from other job applicants. All companies need to look at reducing their carbon footprint. So your knowledge and suggestions would make employers view you very positively. You know, when you present your proposal to your bosses once you get employed, they would want to see returns and cost reductions. Well, for your information, all our projects that we have done here actually resulted in cost reductions and greenhouse gas reductions. When you help to save the environment, you save your costs too. So don't worry about coming up with crazy ideas for your thesis on sustainability, and you may actually see it bearing fruit sooner than you think. This afternoon's presenter, Engineer Kwa, was my mentor when I registered to become a professional engineer. He has been in and around the palm oil industry longer than me and will be delivering his presentation this afternoon. His presentation is about getting the best from technology in sustainable palm oil processing. I urge you all not to miss his presentation. Now, another thing I want to leave you with is, very often people think that palm oil is a very unhealthy oil. But let me assure you that palm oil is actually a very healthy oil, and it has received a lot of negative publicity. I hope all of you do your research so you can give intelligent feedback to your mums and friends about the benefits of using palm oil. The West has done a massive public relations exercise which has demonized palm oil, and sadly, many Malaysians believe it. I think it is important for us to gather the facts so we can know the real truth. Allow me to share with you a bit about palm oil. See, if you look at palm oil, okay, these are the challenges faced by palm oil: sustainability, trans fatty acid, 3-MCPD&G, and more, which I touched upon in my presentation. Now, if you look at the vegetable land use by crop, you will notice that palm oil comprises 36% of the usage of palm oil, of all oils. But it only occupies 6% of land. If you compare that with soybean oil, it provides 26% of production, but it occupies 40% of land. And you can see as you go down the list, right, it gets worse and worse. The most efficient is actually palm oil. The one that actually helps meet the world's requirements is actually palm oil. You can find that palm oil goes into about 72% of all palm oil uses in food industry. Yeah? A lot of your daily use products or even your food that you consume contain palm oil, from your breads to your cakes, to your ice creams, to your margarines and all that. Yeah? And personal care and cleaning, 18%. And again, for biofuel industry, it's about 10%. Huh? So in terms of health, a lot of people may say palm oil doesn't contain good ingredients, but it is not true. Huh? Palm oil is actually a healthy oil. And don't be deceived into thinking, like in the Malaysian or Asian style of cooking, one of the best oils to use for the frying and all that is actually palm oil. To close, I hope you enjoyed the presentation and obtained at least a little bit of info on sustainability and techniques to reduce your carbon footprint, and also about palm oil in general, and also for your career. Again, like I mentioned, don't forget this afternoon's presentation by Engineer Kwa and tomorrow's presentation by Mr. Vision. And yes, thank you. We've also shared some of our work in publications. So this, you can see some of the publications that we've done in environmental pollution reduction, optimizing of a refinery operation. This is more on sustainability, these two topics. This is again on pollution. This is on pollution. This is, sorry, the first one is on 3-MCPD, my mistake. Some work that we've done for palm oil. This is also for improving the quality of palm oil, reducing the contaminants. And these are 2 chapters that we contribute in our upcoming book that's supposed to come out second half of this year. Okay, thank you very much.
All right. Thank you very much, Ayasha, for the insightful presentation. So it's inspiring to know that the green initiative taken by IOI can Berhad in reducing the carbon footprint. So we hope everyone also would follow these footsteps to be a more sustainable being. So next we'll proceed to the Q&A session. So we hope Ayah Shyam could assist in answering them.
I'll try.
All right. Could you please share your screen? Oh, Clary. All right. So for the first question about LNS replaces biodiesel, why don't just use B5 or B10 palm-based biodiesel as a replacement?
I'm not familiar about what is LNS, but I think we are already using B5, B10 in our diesels. And if I'm not mistaken, Indonesia has already moved up to even higher levels, B30, and they are talking about going to B50. Now, in some engines, some of the parts may need to be changed. I think up to about B20, most of the engine manufacturers says, oh, no problem, right? You can use it. But when it goes beyond the B20, there's some engine manufacturers that say some of their rings, maybe the O-rings or some particular parts like hoses and all that, which may suffer from attack by the fatty acids in biodiesel, that may require replacement. So some minor tuning has to be done. But Indonesia has actually implemented quite successfully.
All right, thank you so much, Ayasha. So for the next question, on heat recovery with spiral heat exchanger, isn't using fewer equipment or simplification be more economical to the entire process?
Yes and no. In the case of heat exchange, you may need a certain amount of heat exchange surface. So by actually having the additional surface, you're able to recover more heat. But yes, in terms of pressure drop and energy loss, you may incur more if you have to have multiple equipment. So yes and no. You have to see what works out optimally for your application. CPO washing. CPO washing is actually just adding a small amount of water, let's say in our case, hot water, condensate, is mixed with CPO, say about 5 to 10% water, okay? And it is then sent into a centrifuge, right, to separate the oil and the water. That is how CPO washing is conducted at our site, and also now some of our mills in our IOI have also implemented CPO washing. So they're able to produce CPO with low chloride and low contaminant levels. 3-MCPD is formed typically in the deodorizer in the refinery, but we've also noticed that some amount could form even after the bleaching stage. So the temperatures may allow some of it to form. I guess, again, going back to what we study, rate of reaction and all that, right? So there's some amount forming. And even at the lower temperatures, some amount does form. So when we do tests, sometimes we do see 3-MCPD form even post-bleaching. Yes, are there metal elements? Yes, there are metal elements, because you must remember it is a very intensive mechanical process where pressing is done. And typically you'll find iron and maybe some copper, which are considered as poisons to the iron. So whatever alloying elements that you have in the iron or the steel will end up coming into the CPO as well. So you may find, maybe, I don't know, you may find some chromium and nickel as well, because those are alloying elements that you find in stainless steels. Yeah. Okay. Shell, palm kernel shell, and EFB fiber and mesocarp fiber are 3 of the waste generated in the palm oil mills. Shell is more compact and has got a higher calorific value. So it's the preferred material. And also being denser, it is something that can be easily transported over longer distances, giving it more commercial value. An indication to you will be that Shell is currently selling at about 300 ringgit a ton, whereas EFB fiber will be something like 45 ringgit a ton. Right? So it tells you the scale, and this can change from time to time depending on supply and demand as well. There are industries in Korea, Japan, and even Thailand that try to buy Shell as well. So there are parties here in Sabah who collect Shell and export it overseas. So you see that there is value in Shell. It has got more commercial value. So it ends up becoming more expensive because of its denseness, it's denser, and the calorific value as well. High pressure boilers became a norm in the refineries maybe about 20 odd years ago. Previously, we used to use the thermal oil heaters, but when there was the threat or possibility of contamination of food with thermal oil, it was banned, and all refineries subsequent to that were actually equipped with high pressure boilers. So the high pressure boiler is actually a closed loop boiler. So there is no steam or vapor being sent out. It's closed loop. It goes to the final heater that I showed you just now in my process. Then it condenses and comes back again. So it's just circulating within that loop. There is no discharge of the steam or water. So it's a closed loop. What is the threshold limit for the operating conditions for high pressure boiler? Oh, it depends on your refining temperature. Since it's a saturated steam boiler, the pressure and temperature are correlated. So if you're operating your final heater at say 260 degrees, you probably have 50 over bar. I can't remember offhand, but it will be about there, right? If you're going to higher temperatures, operating at deodorizer at 270 degrees, then maybe you come closer to 60 bar, like that. But the higher the temperature, the more the 3-MCPD form, and GE as well. So now a lot of people are coming down to lower temperatures. Oh, okay, LNG. Sorry, what was the question again? What was the question regarding the LNG? Okay, I'll go to the next question. The next question is regarding physical site visit. We used to do physical site visits until COVID. Sabah universities used to come and visit our plant. The chemical engineering department would bring bus loads of students, and we'll actually have an explanation done to them before we walk them into the site. But for the last 2 years, we've not had any visit. We don't encourage any visits. But there will be a virtual visit tomorrow afternoon, done by our chemist museum, who handles our research and development division. 0 3-MCP and GE achievable? No, I don't think even the soft oils have it. There are limits to how much it can be reduced. The current latest technology is struggling to bring the GE below 1. There's only probably one plant in Malaysia that's able to bring the GE below 1. 3-MCPD, since the limit is 2.5, there are many possible methods of bringing it down to below that limit. The permissible limit for palm in the European market is 2.5 ppm 3-MCPD and 1 for GE. Whereas for the soft oils and lauric oils, it's 1 ppm for 3-MCPD and 1 for GE. Oh, okay. LNG replaces diesel. Again, the issue is regarding the parts inside the burners. The burners have got certain components, and during your warranty period, the suppliers may say no. But yes, whatever diesel that's supplied to our refinery already has got B5, B10 added into it. It's already B10 now. So it's already being used. But once you go beyond that, some parts may need to be changed. We inquired this for our diesel gensets as well. And at one stage, we wanted to use high biodiesel content, but we were warned against it by the engine suppliers. So, and they said our warranty would be void if we used it. So we need to find out what's happening in Indonesia and how they go about doing this. Okay, the last question I see here is, yes, we are complying with the 3-MCPD, which is a 2.5, and GE, it actually kicks in next year, 1st January next year, which is the 1 ppm. We are already able to achieve it. We do not commercially produce it at the moment. Whenever there is a requirement, we do it. And we are developing the process in-house. Same like the 3-MCPD process that we develop it in-house. No, our site doesn't have biodiesel. We only do edible oils. We have lauric oils, we have kernel crushing plant. So it's a very integrated complex. There are not many complexes like this. So you can see kernel crushing plant, refinery, fractionation, palm kernel dry fractionation, export complex, export facility, a jetty, biomass plant, cogeneration, a raw water treatment plant, effluent treatment plant, everything in this complex. So quite a lot of processes here. Interesting for chemical engineers, a lot of processes that you can actually, or you've already seen in your unit operations. Huh?
All right, so I think that's the last question.
Okay.
Okay, thank you, Ayasha, for answering the questions. So I hope everyone have gained much from this Q&A. So before ending this session, may we have a quick photo session, if that's all right to you?
Okay.
All right.
Yeah, can everybody turn on the cams, please? Yeah. Anybody else can open their cams? I'll just take them. So 1, 2, 3. So wait, give me. Yeah. Thank you.
Right. Okay, once again, thank you, Ayasha. So I think next session is the break session. So you guys may feel free to stay here or you can leave and make sure to come back before 12:55 p.m.